Let's take a look at Project 1, Chapter 1. This is the part of the project that corresponds to Lesson 1 of Algebra 2B. If you haven't already, please take a look over this section of the project and read through it. There's context and information that I am not going to include here for the sake of time. I want to try to keep this video as short and efficient as possible. Okay, let's get started. So question 1. The king thinks the AC was particularly inefficient yesterday, but I think the AC is working properly. I determined that the function f of x equals 24 minus 5 cosine pi over t represents the outside temperature in degrees Celsius, where t represents the number of hours past midnight yesterday. I want to calculate the hours during which the air conditioner was cooling the castle and show the results to the king. Okay. Now we haven't even gotten to the question yet, but that was a lot of information, so let's review. The most important takeaway here is this function, right? So we want to understand what this function is symbolizing before we move on to the question. Well, they do explain for us that t represents the number of hours past midnight. So t is telling us the time in hours past midnight. Okay, again, t is time in hours. Now, notice that this is written f of x. Really, that should be f of t. Okay, that was just a typo. We're using the variable t, I think, because it's more helpful. T is just a standard variable letter to use when we're talking about time. So it really should be, again, f of t. So f of t equals 24 minus 5 cosine pi over 12t. So we're saying if we plug in some value for time in hours past midnight, we'll get what? What's the answer we're getting from doing that? Well, this is representing the outside temperature in degrees Celsius. So our function, if I simplify this function, I'm getting degrees Celsius. So you can think of this as our y variable. Okay, so y is temperature in Celsius. Okay, so if I was looking at a graph, my y-axis would be my temperature and my x-axis would be my time. So again, I know it's a little weird because time, it was written f of x, but we really have the variable t here. Try to hang with me on that. Time is going to be represented on our x-axis, temperature on our y-axis, okay? One more time, just to repeat, because it's very important that you understand this relationship. We're saying that we use this equation, we plug in some value t, which represents time in hours past midnight. So for example, if it was 7 a.m., t would equal 7. If it was 1 p.m., I would plug in 13 because 1 p.m. is 13 hours past midnight, right? 12 noon would be 12 hours past midnight. 1 p.m., 1 hour later, would be 13 hours past midnight, okay? So we're saying if I plug in that value for time and I simplify my equation, the result that I get is the temperature in degrees Celsius, okay? Now we're ready to take a look at the question. All right, so if the castle's air conditioner cools the castle when the outside temperature is above 25 degrees Celsius, which inequality or equation would correctly represent this situation? And they give you a couple things to choose from. All right, well, first of all, let's consider, would we be looking at an inequality or an equation? Let's use the context of this, okay? So it says the AC cools the castle when the outside temperature is above 25 degrees. So think about whether the phrase above 25 degrees says to you inequality or equation. And hopefully you're thinking inequality, because wouldn't above be the same thing as greater than, right? So that's what that is signaling here. Above 25 degrees Celsius means greater than. So when our function f of x or f of t, I'm going to write f of x because that's what they have, is greater than 25 degrees Celsius, we use the AC. All right, so now obviously I can't just write f of x, I have to actually write in the function itself, okay? So 24 minus 5 cosine of pi over 12t. Now, all I did, I literally just rewrote the function, okay? 24 minus 5 cosine pi over 12t. And then all I'm saying is, when does this function apply? Well, when the temperature, when T is greater than, or when when the value of this, because this is our f of x, is our function, right? When the value of this entire statement, in fact, let's circle that. When the value of this entire statement is greater than 25, we use the AC. So this is how you would start to write it out. You'd write 24 minus 5 cosine pi over 12t is greater than 25, and all you'd have to do from here is simplify. So how would I simplify this equation? Well, if I were you, I would move this 25, I would simplify by moving this 25 to the other side of the equation, okay? Simplify that, and you will have your answer for this question. So now, let's take a look at question 2. So it says, to solve the problem, which is, we're talking about whether the AC was functional. To solve the problem, you need to find the zeros of the previous equation or inequality over the interval 0, 24, which represents a day. And looking at my presentation now, I realize that it's being cut off a little bit. Don't worry, all the text I have on the screen, I just copied and pasted from your project. So if it cuts off and you feel that you need to read it, just read it in the project. All right, so again, to solve the problem, we need to find the zeros of the previous equation. So the previous equation, this would be your answer from number 1, all right? And they're saying we need to find the zeros. Well, what do we mean by zeros? Well, zeros are the values where we cross the x-axis. So if I had some function, I have a function f of x in yellow, okay? Let's say, and I'm just making this up, this is not the actual function that you guys have. Let's say I had a function that did this, okay? The zeros of this function would be where I am crossing the x-axis. So it would be this point here, that point there, and it looks like it happens a third time right here, all right? So my zeros are also my x-intercepts, all right? The point at which I cross the x-axis. Now, we're asked to do this using a graphing calculator or using technology. So what I've done is I've already graphed the equation. Now, this is not going to be what your graph looks like because I'm just using a web-based, very simple application. It didn't allow me to use the inequality. I had to just use an equation, which is why you're seeing it as an equation instead of an inequality, but it works for our purposes. So, and I'm not showing you what I typed in again because that's the answer to question 1. Hopefully you understand how to type in and graph things on your calculator. If not, almost every calculator has an online tutorial, and I highly recommend that you look into that now at the beginning of class because you will be using technology and you will be using your graphing calculator, whether it be a physical one that you hold in your hands or one online throughout this class. So anyway, I got to this point again. I got to this point by simply typing in the answer that I got for number 1, and then this appeared. All right, and the reason that it's curving up and down is because we have that cosine, but we'll talk about that later in class. So they're saying between the interval of 0 and 24, what are the zeros for this equation? So this purple line that you see going vertically, I plotted that line just so you could see where 24 is. So all you have to do for this question is to graph your inequality, look at the values, specifically the y values of your function between 0 and 24, okay, because we're looking at the hours 1 through 24. Remember, x represents hours after midnight. And I'm just saying, where does it hit the x-axis? So I can see 2 places where the function is crossing the x-axis between 0 and 24. You would look at the x-coordinates of those spots. The x-coordinates are going to be your answer or answers for this question. All right, back to our PowerPoint. So, what are the approximate values? Again, it's approximated. This is not a fill-in question. You just have to select the correct ones or correct zero or zeros. So just do that. Again, use a tutorial if needed on your graphing calculator. So once you find the zeros, we can move on to question 3. And it says, when was the air conditioner cooling the castle? When was the air conditioner cooling the castle? So we're still using the information that you got in your last answer. So if you remember, my graph was doing something, I don't know, let's see, like this, right? This is not an exact representation. I'm just kind of using it as an example. And there were 2 spots, right? There were 2 spots that I saw between the values of 0 and 24, where I had my spots hitting the x-axis. So again, this is just me making up an example that is not the answer to kind of show you what to do. So for the sake of this example, let's say that the value of that point was, I don't know, how about 2.5, and the value of this was, let's say, 10.25. All right, again, these are not real numbers or not real answers. I'm just making them up. So let's say that was what you got. All right, you got that the x-coordinate was 2.50, and then we had 10.250, and those were your answers. So how do I use that information to figure out the times? Well, remember that the x-axis is telling me hours after midnight. So what time is 2.5 hours after midnight? And what time is 10.25 hours after midnight? Remember, you know, when we talk about a decimal, we're talking about hundredths. When we're talking about minutes, well, that's happening in modules of 60, right? So 2.5 hours after midnight, it's not 2:50 a.m., right? It is 2:30 a.m. All right, so notice how I did that. 2 would be 2 hours, and then half an hour after that would be 2:30. What about 10.25? Same sort of thing here. That would be 10 hours and a quarter, right? Well, what's a quarter of an hour? 15 minutes. So that would be 10:15 a.m. Once again, just for sake of argument, say you got an answer like, I don't know, 16. Let's say you got an answer like 16. What time would that be? Well, what's 16 hours after midnight? Well, let's figure it out. So using noon as our sort of gauge, I know that 12 hours after midnight would be noon, right? So that leaves me 4 hours. So what's 4 hours past noon? Well, it's 4 p.m., right? All right, so again, these are just examples to show you how to convert the x-coordinates of the zeros that you got in your last question, how to use that information and turn it into actual times. And then those would be the answers that you select for this question. All right, let's move forward. So once again, you know, if information is cutting off here, please just ignore it. It's all stuff that you can see in your project, and I'll try to size my image a little better next time. Here, you are asked to explain how you created the mathematical equation or inequality in question 1, and how you solved the problem by using technology in question 2. Alright, so assuming that you have followed along here, you should be able to work on this. Again, it's just an explanation. So I'm not looking for a specific answer. I wouldn't say that there is one right answer for this, but I do expect detail, specificity, and conclusion. So what I would say is, you know, you're going to run into these kind of fill-in short paragraph questions quite a bit in projects. So think of them as discussion posts. You know, chances are you're not going to be able to get full credit for just a single short sentence. Think of it like a discussion post, right? Really give me a robust, full answer. Make sure you answer all parts of the prompt completely. Use proper mathematical language, so referring to, you know, using definitions like we talked about, zeros or x-intercepts. Use proper mathematical language and explain what things are as needed. And act like your audience is a classmate who doesn't understand the problem. Okay, so don't type in your answer like you're talking to me and you're going to write it in shorthand because you know that I already know what you're talking about. Act like you're tutoring someone. Imagine that I messaged you for help and I said, hey, I don't get this one. How do I do it? You know, what would your response be? Okay, so again, Think of it like a discussion post. Answer it as if you're explaining it to somebody who does not understand what's happening, and use proper mathematical language. And that goes for the next one. The next question is also a short paragraph or a short answer. This time they say you solved the given problem using technology. How would you do the same thing algebraically? Well, remember, what we did with technology was to find the zeros or the x-intercepts of a function. So we did that using technology, using a graphing calculator. They're just saying, how would you do that algebraically? So hopefully this seems familiar from your earlier math classes. You probably learned how to do this. If it's been a while, I'll give you a hint. Remember that when we looked at the graph, our zeros happened when we cross the x-axis, right? Well, if I zoomed in on this, what's the value of y when I cross the x-axis? Well, the value of y is 0. The x-axis is the line y equals 0, okay? So, again, that's just a little hint to get you started. How would I find the x-intercepts algebraically? Think about what I might set y, what I might set f of x equal to solve for the x-intercepts. And that's everything for Project 1, Chapter 1. Hopefully you found this helpful. I'll see you for Chapter 2.